Welcome to Lesson 22. This is called Equivalent Rational Expressions. And our objective is I can define rational expressions and write them in equivalent forms by factoring and indicating values in which the expression is undefined. So opening thoughts. So just write out two fractions that are equivalent to 1/3 and draw visual models to support your answer. So for example, if you wanted to, you could just draw a line here and you could say 1/3 is equal to 2/6. Okay, or you could have also done this. 1/3 equals 3/9. Okay, or if you wanted to even go farther, now I have 18 pieces, and 1/3 equals 6 out of 18. So, but the point is whatever you multiply your numerator by, you have to multiply your denominator by. So the general rule is if a and b and n are integers, and n does not equal 0, and b does not equal 0, then a over b equals n times a and n times b. Alright, so that's just one of our general rules. Let's move on to the next part. It says which of the following are rational numbers and which are not. So rational numbers, they can ultimately be written as a fraction of two integers. So let's go through these really quick. So 3/4, 3 and 14/100 are rational. Pi is an irrational number. Oops, almost wrote out the 3.14 for that. Would not be right. Pi is irrational. 5 divided by 0. That number does not exist, so that's actually in the neither category. Negative square root of 17, that's irrational. Okay, it does not repeat or have a decimal answer that ends. Let's see here, 1 plus, skipped 23, that is rational. Then 1 plus the square root of 5, because it has that square root of 5, divided by 2 is also irrational. And then -1 and -1 is rational. Sorry, those are blending together for me. And then 6 and 22 thousandths times 10 to the 23rd. And also 0 is rational. Okay? Alright, so now moving on. Let's look at the expressions. So we talked about in the objective indicating values in which the expression is undefined. It's undefined if the denominator ever equals 0. So let's look at the first one, 31 divided by 47. It says what values need to be excluded? None, because it will never, 47 is not 0, okay, and it's always just going to equal 47. For the second one, ab squared divided by 3a minus 2b, there's a couple different places where this has to be excluded. The first place is if a and b both equal 0, the denominator will be 0, and also if 3a equals 2b. That would exclude it, because if 3a equaled 2b, then when you subtracted, you'd get 0. So the next one, 3x squared plus 4. So we're trying to figure out when does that equal 0. So now we have 3x squared equals -4. So x squared equals -4/3. Okay, that in terms of real numbers will never happen. So no real numbers will be excluded. And then finally, b squared minus 7 in our denominator. So when b squared equals 7, okay, that's going to equal 0. So that means if b equals plus or minus the square root of 7. Okay, so that expression exists for every real number except when b equals positive or negative the square root of 7. Flip your paper over to page 2. So this particular chart, this is called a Frazer Model, I believe is what it's called. And it's where you take an idea, rational expression, and you fill out different pieces of information about it. So a description of a rational expression is an expression that can be written as P divided by Q, where P and Q are polynomials and Q does not equal 0. Okay. So examples, 3/5. Okay, 3 is a one-term polynomial. It's just 3. 5 is a one-term polynomial. X squared minus 4x over x plus 1. Okay, with x cannot be negative 1. And here's one more example. A squared plus b squared over a plus 2 times a minus 1. That will work as long as a does not equal negative 2 or positive 1. For characteristics, what can you say about rational expressions? Rational expressions follow similar rules as rational numbers do. Okay, they behave the same way. So non-examples, here's a non-example, x plus 1 divided by 0. You can't divide by 0, it's undefined. So we're just going to say undefined, UND. 2 to the x power divided by 3x is not, because 2 to the x is not a polynomial. Okay, all right. The next part. So it's important to note that the excluded values of the variable remain even after simplification. This little point is huge. So even after you simplify, you still have to go back to your original expression. And you still have to think about when will this not exist. So, for example, for 2x divided by 3x and 2/3, these are equivalent everywhere except at x equals 0. Okay, and that's because at x equals 0, 2x over 3x is undefined. And also at x equals 0, 2/3 is just 2/3, so it doesn't affect the second number. For the second one, they're equivalent at everything except holy cow, okay, except at x equals 5. Okay. All right, so it's undefined there. For x minus 3 over x squared minus x minus 6. Okay, so looking at this one, and this is giving me a hint right now of something I can do with this polynomial expression. X minus 3 over x squared minus x minus 6, I can factor that out. Okay. All right, and when you simplify, you're going to get, this would be 1 over x plus 2. So they're equivalent everywhere except at two values where this would equal 0. And hopefully you're starting to catch on to that when x equals 3 or negative 2. Then they are not equivalent because the first expression is undefined at those values. Second example says consider the following rational expression 2 times a minus 1 minus 2. It says turn to your neighbor and discuss the following. For what values of a is the expression undefined? So we just have to simplify the denominator. Okay, there's a couple different ways we can do this. So I did it this way. I just set 6 times a minus 1 minus 3a equal to 0. So I get 6a minus 6 minus 3a equals 0, 3a minus 6 equals 0, 3a equals 6, a equals 2. So when a equals 2, that particular expression is undefined. Okay. All right, moving on. Okay, for exercise A, it says reduce the following rational expressions to lowest terms and identify the values of the variables that must be excluded to prevent division by 0. So we're simplifying them down to the original terms, but then we're looking back and saying, okay, if you look at the original, okay, I think I might have just misspoke there. We're simplifying them to lowest terms, not original terms, lowest terms, but then we look back at the original and we say, okay, what do we need to exclude for values of x? So I'm going to do the first one right now. Okay. Don't be tempted, well, you might be tempted, but you cannot just do that and get rid of them that way, okay? That is a big no-no. Can't do that. When you divide something in an expression, that would only work if everything in here was being multiplied by x plus 1. Every term in the expression had to be factored out by that. So I'm going to undo that. All right, so here we go. I'm just going to distribute. And I get 2x plus 2 plus 2. And on the bottom, I've got 2x squared plus 5x plus 3 minus 1. So I'm going to simplify this even more. 2x plus 4 over 2x squared plus 5x plus 2. Okay, so I'm going to take it up here now. This now becomes 2 times x plus 4. My denominator, hello, not x plus 4, x plus 2. I just ate lunch, and I can tell that I'm digesting because my brain is not working. And then the 2x plus 5x plus 2, I can factor that into 2x plus 1 times x plus 2. Now everything is being multiplied, so I can simplify those out. So in order to figure out what variables x cannot equal, I just plug 2x plus 1 and set it equal to 0. And this will tell me what I can't have. So 2x equals negative 1/2. Oh, hello. Negative 1. Got ahead of myself. Ooh. So x cannot equal negative 1/2. However, that's just for this one. Remember, we have to look at the original. Don't forget about this guy. When does this equal 0? This equals 0 when x equals negative 2. So for each of these cases, at x equals negative 1/2 and x equals negative 2, it's undefined. So it cannot equal that. All right, I'm going to do one more, and then I'm going to stop this video, and now I will start a new one. Okay. Let's look at letter B. I have x squared minus 6 times 5x plus 10x. So I'm going to factor this x squared minus x minus 6 into x minus 3 times x plus 2. I'm going to factor out a 5x here, and it's going to be x plus 2. So I know that my x plus 2's will disappear, so I get x minus 3 times over 5x. Okay, but remember, we have to look back at the original polynomial expression, and we have to figure out which variables have to be excluded there as well. We know that x cannot equal 0, because 5 times 0 would be 0, and that would give you a denominator of 0. X can also not equal negative 2. Alright, so this is part 1 of lesson 22. Click on the next video to get part 2.